Something has appeared in the earliest corners of the universe, something so dense, so radiant, and so utterly alien that it shook the very foundations of cosmology. When the James Webb Space Telescope turned its golden mirrors toward the edge of time, it didn't just capture galaxies or stars. It captured anomalies, countless crimson specks glowing faintly in the abyss, like dying embers scattered across the dawn of creation. But these weren't stars. And they weren't galaxies as we understood them. Their very existence defied everything we thought we knew about gravity, light, and time. For over 2 years, these faint red dots baffled astronomers. They suggested something profound, that the universe we know today might not always have obeyed the same laws. That physics itself may have once played by different rules. It all began with what scientists first dismissed as a data glitch. In late 2022, Webb began sending back deep field images filled with tiny red points of light. Small, yes, but impossibly bright. At first, astronomers assumed these were distant, redshifted galaxies, their light stretched by cosmic expansion. But when they studied the data, a strange truth emerged. These dots weren't red because they were moving away. They were red because they were smothered. Wrapped in dense cocoons of dust that absorbed every other wavelength of light, leaving only the deep crimson glow of trapped energy. And they weren't rare. Webb found them everywhere. In almost every deep image, these red embers glimmered like ancient signals. When astronomers calculated their distance, the shock was immediate. These objects existed just 600 million years after the Big Bang, and by a billion years later, they were gone. A cosmic window so brief it could be missed in a blink of galactic time. Yet in that moment, they flared into existence across the universe, and then vanished. At first, scientists thought they were just compact young galaxies, dense knots of newborn stars forming faster than anything seen before. But the numbers didn't make sense. The brightness was too intense. The inferred masses were far too high. Each was only about 1% the size of the Milky Way, yet they glowed with the light of galaxies thousands of times larger. Their densities should have torn them apart, stars colliding, supernovae exploding, gravity shredding them from within. By every rule of physics, these structures should not exist. But Webb doesn't lie. As the data piled up, the contradictions deepened. Some astrophysicists suggested these red dots might be influenced by dark matter, invisible scaffolds of gravity bending and amplifying their light. Others whispered of something even stranger, exotic physics, hidden forces, perhaps remnants of a universe that existed before the Big Bang. Because if these were galaxies made of stars, then the laws governing matter, time, and gravity were incomplete. Then came the boldest idea yet, the one that flipped the entire story on its head. What if these weren't galaxies at all? What if they were monsters, supermassive black holes born impossibly early, wrapped in the shrouds of their own creation? The light we saw wasn't from stars. It was from the blinding fury of matter spiraling into black holes, forming brilliant accretion disks that outshone entire galaxies. This theory made sense of their brightness and compactness, but it posed a terrifying question. How could such black holes exist so soon after the Big Bang? In the modern universe, black holes are the quiet hearts of galaxies, small fractions of their total mass. But in these ancient red dots, the black hole seemed to be the galaxy, dominating nearly all its mass. That means the traditional order of creation, first stars, then galaxies, then black holes, might be wrong. Maybe it was the other way around. Maybe black holes came first, and galaxies formed around them. If true, this would rewrite the story of cosmic evolution itself. The early universe may not have gently evolved. It may have exploded into complexity, sculpted by gravitational giants that appeared before the first true galaxies ever formed. Still, the scientific community hesitated. Without clear proof, even the most extraordinary data felt inconclusive. Then came the breakthrough, hidden not in light but in hydrogen. When astronomers analyzed the emission lines from these mysterious objects, they found something astonishing. The hydrogen bomber lines, the spectral fingerprints of motion, were unnaturally wide. In astrophysics, broad emission lines mean one thing: speed. Gas orbiting at thousands of kilometers per second around something unimaginably massive. The only possible culprit was gravity, the kind only a black hole could generate. In these objects, the gas was moving 10 times faster than it does around the black hole at the center of our Milky Way. No star cluster could explain it. That was the smoking gun. The little red dots weren't galaxies, they were engines. Black holes, growing at terrifying speed in the shadows of the early universe. The laws of astrophysics weren't broken, they were simply too small to contain what Webb had found. But then, the silence. These objects, so luminous, so energetic, should have been flooding the cosmos with X-rays, the signature of black hole activity. Yet none were detected. It didn't make sense, until someone realized the answer wasn't in what we saw, but in what we couldn't. The density of the surrounding gas was so extreme that X-rays couldn't escape. They were absorbed, scattered, and buried within the dust itself. The universe was hiding its monsters, black holes that grew unseen, smothered in cosmic fog. This silent growth phase may have built the very foundations of modern galaxies, including our own. James Webb didn't just find anomalies. It uncovered a missing chapter of the universe's story, an age of darkness where light was trapped, devoured, and reborn as structure. A hidden era when the cosmos was ruled not by stars but by gravity itself. And perhaps, that era never truly ended. If it happened once, it could still be happening now, in galaxies so distant, so dust-choked, that even our best instruments can't pierce the veil. The red dots may have simply changed form, evolving into something else. Something still feeding, still shaping the cosmic web in silence. This realization forces a haunting question. Have we been looking at the wrong things all along? For decades, astronomers have built their models on what's visible, clean light, neat equations, predictable laws. But Webb is showing us a universe that's messy, violent, and raw. A universe that didn't wait for the rules to catch up. These red dots represent more than cosmic curiosities. They are fossils of chaos. The fingerprints of an age when physics itself was being forged, when galaxies weren't assembled, but torn into existence. If these black holes truly preceded the galaxies around them, then our cosmic timeline is off by billions of years. Everything, from the birth of stars to the evolution of structure, may need to be rewritten. And then, they were gone. Every one of these red dots, hundreds across the sky, vanished from the cosmic record 1.6 billion years after the Big Bang. Not gradually. Instantly. Like sparks burning out. Perhaps they became quasars, the brilliant hearts of galaxies powered by black holes, or perhaps they collapsed into something darker, quieter, beyond detection. Whatever happened, it left no survivors. The universe moved on, and the monsters of the early cosmos slipped into myth. Or did they? In recent years, astronomers studying compact starburst galaxies stumbled upon something eerily familiar: the so-called green peas. They exist billions of years later, but share unsettling traits with the red dots: compact size, incredible brightness, short lifespans. Could these be echoes? Evolutionary cousins? Or just a new manifestation of the same ancient process repeating across time? If the red dots were the first act of cosmic creation, perhaps the green peas are its reprise. A whisper that the universe never truly stopped building in chaos. Webb has done more than capture light. It has revealed shadows, relics of realities we never knew existed. The early universe wasn't peaceful. It was a battleground of creation and destruction, where matter and energy fought for dominance, and the rules of physics were still being written. The little red dots were never supposed to exist. They weren't in the models, or the equations, or the textbooks. Yet there they are, scars burned into the first billion years of spacetime. And what they tell us isn't just that physics might be incomplete, but that the universe itself is wilder, faster, and more creative than we dared imagine. The James Webb Space Telescope hasn't just expanded our vision, it has exposed how fragile our understanding truly is. For centuries we thought the cosmos evolved by order. Now we see it may have thrived on rebellion. The early universe didn't follow the rules, it made them. So what else is hiding in that first light, waiting to rewrite everything we think we know? The little red dots may be gone, but their legacy endures, as a message from the edge of time itself.